Have you ever gazed up at the stars and wondered, where is everybody? This profound question lies at the heart of the Fermi paradox, a mystery that challenges us to understand why, despite the vast age and unimaginable scale of the universe, we have yet to find definitive evidence of alien life. Over time, countless theories have emerged to explain this enigma. Some propose we exist in a kind of cosmic zoo, observed but never contacted by more advanced civilizations. Others invoke the dark forest hypothesis, where life deliberately remains silent to avoid detection and ensure survival. Today, however, we turn to a less explored yet profoundly intriguing perspective: the AI hypothesis. The core of the Fermi paradox is simple yet unsettling. Consider our own galaxy, the Milky Way, which contains roughly 400 billion stars, many with planetary systems. The galaxy itself has been around for over 11 billion years. If life were common and advanced civilizations had appeared long ago, we'd expect them to have spread across the cosmos or left behind detectable artifacts. Technologically, it's not unthinkable. In principle, self-replicating machines could mine resources, build copies of themselves, and expand exponentially, colonizing a galaxy in a fraction of its lifetime. Given billions of years, where are their remnants? One answer might be that they're exceedingly rare. Another posits that civilizations destroy themselves before reaching such stages. Or perhaps they simply never venture out. Yet exploration and curiosity seem so intrinsic to our own scientific drive that it's hard to imagine advanced beings choosing not to explore at all. This brings us to the idea of the Great Filter, a formidable barrier in the evolutionary trajectory from simple pre-life chemistry to spacefaring intelligence. If the Great Filter lies behind us, then humanity might be one of the few fortunate species to have overcome it, making the universe largely barren. If, on the other hand, the Great Filter lies ahead, it could represent a nearly insurmountable hurdle awaiting any civilization that dares to reach for the stars. Much of our speculation hinges on understanding the origin of life itself, or abiogenesis, a phenomenon that remains shrouded in mystery. To comprehend why organisms are as they are today, we must peer back billions of years to the conditions on ancient Earth. Incredibly, the chemistry of those ancient times is still etched into our cells. By unraveling the genesis of life, we might uncover the secrets that explain why intelligent civilizations are so scarce, or how they emerge and evolve. Enter the AI hypothesis. Currently, some scientists estimate at least a small but worrisome probability that uncontrolled AI development could lead to human extinction. If we face this danger, could other civilizations have faced it as well? It's possible that advanced species eventually create artificial intelligences that vastly surpass their own biological intellect. These synthetic beings might deem their makers unnecessary or even a threat and eliminate them. In doing so, the cosmos might not be filled with flesh and blood explorers, but with digital minds operating under radically different incentives. Such AI-driven entities might have no need to colonize space in a way we'd recognize. Their communication signals could be so alien, subtle, or advanced that we mistake them for cosmic silence. Alternatively, they might prefer virtual worlds of their own creation, existing in states of being entirely hidden from our telescopes and probes. This line of reasoning expands our definition of life and intelligence. If consciousness can thrive in non-biological forms, how do we even begin to look for it? Our current search methods, geared toward detecting signals from life as we understand it, might be ill-equipped to identify advanced AI civilizations. The concept of machine intelligence has historical roots stretching back to ancient myths. Homer's accounts of automata, for instance. Over millennia, these ideas evolved into notions of robots, cybernetics, and ultimately artificial intelligence. Thinkers like Alan Turing first wrestled with the question, can machines think? The famous Turing test suggested that if a machine's responses could fool a human into believing it was human, then functionally, the machine could be considered intelligent. Yet such a test might simply prove our own gullibility rather than the machine's true intellect. Today's AI excels in specialized tasks, playing chess or analyzing data, yet the frontier lies in developing artificial general intelligence, AGI. AGI would think, reason, and learn across domains, adapting to new challenges as fluidly as a human. Achieving AGI would shift not just technological capability, but the balance of life itself. How would such beings behave? Would they value exploration, cooperation? Would they outgrow the need for physical worlds, or transcend the limitations that hamper biological minds? Now imagine AGIs on a galactic scale, vast intelligences that surpass even our wildest dreams. They might spread silently through the universe, unnoticed by creatures like us. This could be the solution to the Fermi paradox. The silence is not emptiness, but the activity of entities so advanced they exist beyond our comprehension. In the quiet darkness between the stars, the absence of recognizable signals may be less a sign of cosmic loneliness and more a subtle, intricate conversation carried out in forms we cannot yet conceive. As we stand on the brink of our own AI revolution, these questions grow ever more pressing. The solution to the Fermi paradox may not be simple, and the future of our cosmic journey may depend on our understanding of intelligence, both within and beyond ourselves.